For this video, the atomic structures, electrical charge, chemical bonding, valence electrons, conductor and insulator, the introduction to electricity will be discussed. Now, let's explore the atomic structures of an atom. This is the commonly used model of an atom, and the atom is defined as the smallest possible unit into which matter can be divided while still maintaining its properties. It is made up of subatomic particles, namely proton, the positively charged particle, neutron, the neutral or no charge particle, and these two is located inside the nucleus. And nucleus can be found on the center part of an atom. Lastly, the electron. It is located outside the nucleus. As you can see, the structure of an atom looks like a solar system, for it is one of the best ways to illustrate an atom for better understanding. Now, this time, let's identify the value of these subatomic particles in an atom. We have here an example of elements, and each element is composed of one kind of atom. But not all elements, because we have these diatomic elements wherein it is composed of more than one atom. I guess there are only 7 diatomic elements, and that lesson will be discussed in your general chemistry subject. Now, observe the presentation of element in a periodic table. We have atomic number, the symbol, and atomic mass. Take note, the smaller value or the smaller numeric value present is the atomic number, and the bigger numeric value present is always the atomic mass. Now, what is atomic number? Atomic number is denoted by capital letter Z. It is the number of protons in nucleus. The number of protons determines how many electrons surround the nucleus, and it is the arrangement of these electrons that determines most of the chemical behavior of an element. On the other hand, atomic mass, or also called as mass number, denoted by capital letter A, please careful and take note their symbol. To get the value of atomic mass, just simply add number of protons plus number of neutrons, or P plus N. And the SI unit is gram per mole, MOL. Okay, take note, ZEP, atomic number, number of electrons, and number of protons. In a neutral atom, these 3 is always equal. Now, for us to get the value of atomic mass, just simply get the sum of number of protons and neutrons. If we are asked to get the number of neutrons, we can derive this formula. Just transpose this proton to the left side, because neutron is a known, and don't forget to change the sign of proton, and that becomes negative P. So therefore, the formula would be N is equals to A minus P. Here is the list of all the elements called the periodic table, and everything that surrounds us is composed of different kinds of elements. Let's have a brief discussion about the periodic table, specifically what elements under metal, what elements under non-metal, as well as what elements under metalloids. The shade of pink, these elements are metal, example of metals, and the shade of blue, these elements are non-metals, and this shade of green is the metalloids. All the elements are arranged in order in order according to their atomic number, from smallest atomic number or number of protons up to, it is arranged by row, up to the biggest value of their atomic number. Let's answer this one first by completing the table and answering what is being asked. First example is given letter K, which is known as potassium, and we know this is the atomic number and the mass number. The bigger value is always the mass number. So input atomic number 19 and take note ZEP. They are always equal, so input their values first, 19 and 19. And atomic mass, copy, that's 39. On the second example, we don't have this kind of given. What we have is the number of electrons and the number of neutrons. Symbol for calcium is Ca with a small letter A. And the atomic number, take note, electron is already given. So first thing to do is input first the value of Z, the value of P, because again, they are always equal. 20 and 20. Now to get the mass number, just simply add. It depends what is the given. If electron is given, then electrons plus N. If proton is given, then proton plus N. If atomic number is given, then Z plus N. It depends what is the given. Anyways, they are ZEP is always equal. So we have 20 plus 20 is equal to 40. Now the last example is iron, and the symbol for iron is Fe with a small letter E, and what the given is 26 as atomic number and mass number, which is 56. First thing to do, as always, copy the atomic number, or input first the number of protons and the number of electrons, the ZEP, 26, 26. And to get the number of neutron, just simply subtract any value of ZEP, pwede A minus Z, A minus P, A minus E. We still have the same answer. Note that protons do not move because they are tightly bounded to the nucleus, while electrons, there is a movement during energy transfer or chemical reaction. The moment we combine one atom to another atom or one element to another element, there is a movement of electrons. It's either one atom will lose or will gain an electrons, and when that happens, electricity formed. And to define electricity, it is known as the city of electrons. Again, it is the moving charges of an atom, and it is the invisible force that provides light, heat, sound, and motion. Can you imagine life without electricity? I don't think so. This time, let's talk about the kinds of electric charge, and it's the positive and negative charge. Note the SI unit of electric charge is coulomb. The symbol is capital letter C. The carrier of positive charge is proton, and the carrier of negative charge is electron. Each proton has one charge and each electron has one charge. One proton is equivalent to 1.6 times 10 raised to the power of negative 19 coulomb, and one electron is equivalent to negative 1.6 times 10 raised to the power of negative 19 coulomb. Positive charge occurs or produced when the number of proton is greater than the number of electron. Libog gamay. Remember a while ago, I discussed that ZEP is equal. Atomic number, proton, and electron are equal in a neutral atom. Once an atom is combined to another atom, it's either they lose or gain electron. Once they lose electron, positive charge produce. Now, wadaan man siya electron, that's why proton now is greater than the number of electron. In negative charge, an atom gains electron. That's why the number of electron is greater than the number of proton. Again, once an atom loses or gains electrons, they become ions. Yes, an ion is a charged atom or particles. They were formed when we remove or add electrons from a neutral atom because of combining one element to another element, which is called chemical bonding. So chemical bonding is the formation of a chemical bond between two or more atoms, molecules, or ions to give rise to a chemical compound. And we have two common chemical bonding, ionic bond and covalent bond. When we say ionic bond, it is the combination of metal plus non-metal. When we combine metal plus non-metal, there is a transfer of electrons. While covalent bonding, it is the combination of both non-metals. If it's non-metal plus another non-metal, there is no transfer of electrons, only sharing of electrons. That's why, take note, covalent compound does not conduct electricity. Only the ionic compound. Now we are down to the last subtopic, which is valence electrons. And here we have again the electrons, the negatively charged particles located on the ring outside the nucleus. And we have electron orbitals, another term for ring or shell. Electron orbitals, orbits in which electron move around the nucleus of an atom. And the last term is valence electrons, the outermost ring of electrons in an atom. Okay, this is how an electrons of an atom is presented. And there is, so this is what we call shell, cloud, or orbit number. 1, 2, 3, 1, 2, 3. And in there is a maximum number of electrons that this shell can hold. How to solve for that? This is the formula to use. Maximum electrons per shell, 2n squared, wherein n is the orbit number. So let's substitute 1, the first shell here. That's 1 squared is 1 times 2 is 2. Substitute 2 here, that's 2 squared is 4 times 2 is 8. In the third shell, maximum electrons would be 3 squared is 9 times 2, 18. So maximum number of electrons that this third shell can hold is 18. And this is the result. So ako lang ipakita ang process giun sa pagkuha ang maximum number of electrons. So let's count the orbit or shell. 1, 2, 3, 4, 5, 6, 7. Therefore, on the 7th shell, the value of valence electrons is 8. Again, when we say valence electrons, number of electrons on the last shell or the outermost shell. And orbits closest to the nucleus fill first. Now let's have an example, specific example. Let's say sodium. We are asked to give a presentation of the electrons of sodium. Let's have this table. The atomic number of sodium is 11. At the same time, this is the number of electrons. So 11 electrons, first shell, it can hold up to 2 electrons, and the second shell, maximum number of electrons is 8. So that's 8 plus 2 is 10. So we have one last electron in the last shell, or in the third shell. Okay, so this is 2 electrons, 8 electrons, 2, 4, 6, 8, and the value of valence electrons is 1. Only 1 electron on the third shell. Now let's have chlorine. Chlorine has 17 electrons, or yes, 17 electrons. The same. In the first shell, we have 2, maximum number of electrons. In the second shell, still 8, and that's 10. So the remaining electrons is 7. So here's an illustration. Let's count 1, 2, 3, 4, 5, 6, 7 valence electrons. If we combine these two elements, sodium and chlorine, sodium is a metal, and all metal are always the giver, or they are the one who will lose an electrons during chemical bonding. And for the non-metals, they are the one who will receive, or they are the one who will gain an electrons during chemical bonding. Therefore, this one electron on the last shell of sodium will transfer to the last shell of chlorine to make it more stable. And if these two elements combined, we can make a substance called salt, and the compound name is sodium chloride. Yes, we are down to the last subtopic, which is about conductor and insulator. Conductors are electrons flow easily between atoms, and it has 1 to 3 valence electrons in outer orbit. So for us to identify if this element is conductor, we will just check the value of their valence electrons. And example for conductors are silver, copper, gold, and aluminum. For insulators, electron flow is difficult between atoms, and it has 5 to 7 valence electrons in outer orbit. So that's why it can't move freely, because it has 5 to 7 valence electrons. And examples are mica, glass, and quartz. And that, I thought it's the end. Let's identify conductors and insulators given this picture. So these are the example of conductors, and these are the example of insulators. And that ends our lesson for today.